Nuclear physics, the history of nuclear physics, is a fascinating look into how ideas and theories are created and then evolve over time. Now, we often think about Newtonian physics as telling us a lot about what we need to know about the world around us, and it does tell us about the big world around us. But all of that is built on smaller building blocks, and that's what we're going to look at in this topic on nuclear physics. You're probably sitting on a chair at the moment. It's holding you up, it's solid. It's very reasonable to assume that it must be made of solid material. But of course, we know that it's not. It's mostly empty space. If you haven't already, go back and look at all the lesson videos on IGCSE radiation, because you need to know all that content well and explain it. Go and watch them now. Okay, so the alpha particle scattering experiment had two major results. One, the majority of alpha particles pass right through, only deflected through small angles, less than 10 degrees. This tells us that most of the atom is empty space. The volume of the nucleus is much smaller than the volume of the atom. A very small proportion were deflected through large angles, more than 90 degrees. This tells us that mass and charge are concentrated in a very small nucleus. That nucleus is very small and massive. It has a large mass. The nucleus consists of protons and neutrons, and you may have learned that they have a mass of 1, but that's not really correct. What's the unit? We should say that they have a relative mass of 1, but then what are we comparing them to? The easiest thing to do is to compare them to one another and come up with a new unit. And we're going to call that unit the Unified Atomic Mass Unit, and it has the symbol U. A proton has a mass of 1.0072766 U, whilst the neutron is 1.0086654 U. Now obviously they both round off to 1 U, but in reality the neutron has a little bit more mass, which oddly enough means that the proton is more stable than the neutron. So the GCSE content and those little bits of extra fact are what you need to be able to get into this topic at A level. We're going to look into things in more detail. What's a beta plus particle? Looking at antimatter. Looking at exactly why that value for U isn't exactly the same as the mass of a proton, for example. But for now, make sure that you fully understand what we've covered so far, and make sure that you can describe things in nice, clear detail, and maybe try a few questions.